our last discussion, our last meeting, no? Okay, basin kaingon mo nga na class-classes mo dito. Na-record na ba ni? Na-record na, no? Okay. Okay, let's start na. For definition, many structural members can be treated as actually loaded columns or as beams with only flexural loading. Most beams and columns are subjected to some degree of both bending and axial load. Now, from the topic itself, beam columns, now, for example, in this figure, you have here, okay, this is especially true of statically indeterminate structures. So, the beams and also the columns were subjected to both axial loading and flexural loading. No? For many structural members, however, there will be a significant amount of both effects, and such members are called beam columns. For example, this figure here, you have here the the frame, no? For example, that column AC, no? That is actually subjected to both this point here, this A and C. Because of these lateral loads, no? For example, I think, wind load and, for example, earthquake loads, this column will be subjected to axial load and also bending, no? Because of also these vertical loads at A, B, no? And this one, this, kana siya. And also this beam CD, no? At C and D, nana siya axial forces and also bending force. So these members are called beam columns. No? We have here gitawag nga interaction formulas. So the relationship between required and available strength may be expressed as the required strength divided by the available strength should be less than or equal to 1.0. This is actually the same concept with what we discussed, no, earlier, what I sa videos, that the required strength, that is, this is from the applied loads divided by the available strength. This is the actually the design loads for LRFD and the allowable load, design strength for LRFD and allowable strength for ASD. No? Ang ratio na should be less than or equal to 1.0. Or if you cross multiply that one, the required strength should be less than or equal to the available strength. This is actually the same with this concept for compression members. The strength are axial forces. Now, for example, for LRFD, we have this, the ultimate loads, P sub U. This is from the combined loads or the factored loads divided by the phi sub C. This is the resistance factor times the nominal strength should be less than or equal to 1.0. As well, for ASD, naglahi lang siya for the, this is the allowable strength sa ubos, which is equal to nominal strength divided by the factor of safety, no? Should be less than or equal to 1.0. The P sub A, this is the applied loads, no, or the load combination for ASD. Further, for interaction formulas, this concept or this relationship can also be expressed into this general form, no? The P sub R, the ratio of the P sub R and P sub C, where P sub R is the required axial strength and P sub C is the available axial strength, should be less than or equal to 1.0. No? This is for axial, no? Axial loads lang siya. How about we have, because the beam columns is subjected to both axial and bending man, no? So the interaction formula will be like this one, no? If more than one type of resistance is involved in equation 1, can be used to form the basis of an interaction formula. The sum of the load to resistance ratios must be limited to unity. For example, if both bending and axial compression are acting, the interaction formula would be this this term here, the first term would be the axial term, and the second term would be the flexural term or the bending term. No? We have here the P sub R. This is the required strength divided by the available strength. The M sub R, this is the required moment strength, and the M sub C is the available moment strength. For LRFD, this M sub R is equal to M sub U, no? And for ASD, this M sub R is equal to M sub A, no? Which is from the applied loads, no? Or the load combinations. And the M sub C, which is the available moment strength, for LRFD, this is equal to the Phi sub B, this is the resistance factor times the nominal strength. And for ASD, this is equal to the nominal strength divided by the factor of safety. But how about comb for biaxial bending? There will be two moment ratios. For example, you have here the cross section, no? The steel. This cross section of steel, we have here the y-axis and the x, di ba? X-axis. So, meaning biaxial bending, nakay-bending sa x, along x, and you have also the bending along y. So, that the moment term, no? Kaning moment diri, mahimo na siya og MRX, M sub RX over M sub CX plus M sub RY over M sub CY, no? Ma-divide siya into 2, no? Kay biaxial bending man ka. And plus this axial term, no? Should be less than or equal to 1.0. Where the x and y subscripts refer to bending about the x and y axis. Equation 2 is basic for the ASC formulas for members subject to bending plus axial compressive load. Two formulas are given, one for small axial load. So, natay two conditions, no? Two cases, no? And lahi-lahi siya. We have one for small axial load and one for large axial load. No, later, ato siyang ma-explain. If the axial load is small, the axial load term is reduced. So, take note of this one. If the axial load is small, the axial load term is reduced. While for large axial load, the bending term is slightly reduced. This is from AISC Chapter H, Design of Members for Combined Forces and Torsion. So, to realize this one, no, kani siya concept is this one. For the ratio P sub R over P sub C, this is the required strength divided by the available strength. If this is greater than or equal to 0.2, meaning the axial term is large, no? If the axial load is large, that is greater than or equal to 0.2, the bending term is slightly reduced. So, mo nang naakay coefficient diri nga 8/9, no? If this is the case, no, the P sub R over P sub C is greater than or equal to 0.2. But otherwise, no, if the P sub R over P sub C is less than 0.2, meaning the axial load is small, you have to reduce also the axial term. That is kaning gidivide nimo og 2, no? Na ay 2 sa denominator plus this moment term should be less than or equal to 1.0. These requirements may be expressed in either LRFD or ASD form. All right. Okay. This one is the general term, no? The general formula. But if we apply now the LRFD interaction equation, so this P sub R will be mahimo siyang P sub U, and the P sub C or the available strength will be equal to the resistance factor times the nominal strength, no? This one for if the actual load is greater than or equal to 0.2, you have here the coefficient 8/9, no, at the moment term, no, multiplied at the moment term. So to apply this LRFD equation, the P sub R, no, as I've said kanina, will be P sub U, and the P sub C will be this P sub C times the nominal strength, no. And the same with the moment, no. This M sub R will be mahimo siyang M sub U, and if there is this biaxial loading, so there is moment at X and there is moment at Y. So, na siya M sub UX plus M sub UY. And kaning sa ubos, the M sub C will be mahimo siyang P sub B times the nominal moment strength plus the at along y-axis, no? Should be less than or equal to 1.0. The same with this second case, no? If the P sub U over this is actually P sub R or P sub C, if this is less than 0.2, your actual term, there is 2 sa denominator na part, no? Ma-divide siya into halves, this actual term. And ang moment is as is, should be less than or equal to 1.0. This is for LRFD, no? LRFD. For ASD, actually, alisdan ra ni siya nimo og this one, no? Maalisdan ra ni siya ang imong design strength. Mahimo siyang allowable strength, which is equal to P sub N divided by the factor of safety, no? For this one, for this case, for ASD interaction equations, no? P sub A over P sub N over factor of safety greater than or equal to 0.2. So, you have here the coefficient 8/9 at the moment term. Then, as is ang imong actual term, no? Then, mahimo ni siya for ASD because it's ASD. So, nominal strength divided by the factor of safety. The same with the moment, no? Siya. And, for if this is less than 0.2, no? This second case. So, the same with LRFD, your actual term will have this denominator, denominator 2. Ma-half siya, no? Ma-assist ang imong moment. So, I think we're ready to answer the example. We have this example. The beam column shown in figure 6.2 is pinned at both ends and is subjected to the loads shown. Bending is about the strong axis, no? Strong axis. So that this is at x-axis, di ba? Determine whether this member satisfies the appropriate AISC specification interaction equation. So you have here the beam column and subjected to axial load. You have dead load 35,000 PSI kilo, this is pounds. And the live load 99 kuan namay kuan naman koy kuan Gastorya. Sorry. Sige, padayon ta. So na siya dead load and live load, no? Axial load. And also the lateral loads, no? This 5,000 pounds and 12,000 pounds nga lateral loads, dead load and live load. So the beam is wide flange 10 by 49. A992 steel, meaning A992 steel, the Fy of this one, yield strength is 50 KSI, no? 50 KSI. And still, we are required to determine if this section or if this shape, no, W10 by 49 is appropriate, no? Or mupasar ba siya when it comes to, or is appropriate, satisfies the appropriate ASE specification interaction equation. So, once again, itong interaction equation is this one, di ba? For LRFD, this one. So, we have to determine first this term, the resistance factor times the nominal strength, and this term, no? The moment. But kung inyong tanawon, actually, dili siya biaxial, no? So meaning, the second term here in the moment is, this will become 0, no? Okay, later now, okay. From the column load tables, the axial compressive design strength with W10 by 49 with FY 50 KSI effective length. Okay, tanaw ninyo pin at both ends, no? Pin at both ends, meaning the K of this beam column is equal to 1.0, diba? For pin at both ends. So, the effective length, the K times L, will be equal to 1.0 times the length, this 17 feet. So that KL is 1.0 times 17 is 17 feet, no? And from the column load tables, this is from the AISC tables, no? This W10 by 49 and FYKSI. So, tanaw na to ni siya sa table. Actually, na-discuss naman ni siya na ako, no, sa atong previous na on how to determine this automatic, this P sub C, or this resistance factor times the nominal strength sa table, no? We try to see in the table. This is column load tables na I think that is table. Table 3. I think that is table 3. And W, table 3 ba ito? Moment. Sa atong kalitaan. Sub X. Moment. Okay. Isa. Ano makita ganina? Madumduman ito ninyo klasan sa itong table. Isa. Moment. Kamitang. This is piece of 3-10 D scan sana design shapes. Moment naman ito isa. Sa ako sa nandong ko. Ito isa ha. Tomate. Kalimut ko sa ito nga. Tingin ko lang channeling. Okay, 4-1. 4-1 ay. 4-1. Okay. FY 50 KSI at W flange W10 by 49. Ay, this one. Maklaro niyo ang table? Na-share ba na ko? Otro? Hello? So, okay. So, I think nakita rin ninyo, no? This one, no? The piece of C. And we have to, this is the effective length, KL. So, for 17, no? 17 man itong ganina. 17. So, naa siya for W10 by 49. For LRFD, this is 404 kilopounds. 405. Okay, asan siya gikan? W10 by 49. Okay, W10 by 49. So, in sa table, no, 404, pero yung gigamit diri is 405 kilopounds. But this is sa 404 kilopounds. But stick lang ta sa 405 now, which is from the example. So, this is from the table 4-1, no? So, since bending is about the strong axis design moment, this P sub P times nominal moment force C sub B 1.0 can be obtained from the beam design charts in chapter 3 of the manual. So, we're done with finding this term, no? For LRFD solution for W10 by 49. So, this time, we have to find, no, in the table also, for C sub B 1.0. This C sub B this is the coefficient for the moment gradient, no? But actually, dili 1.0 ang moment ani nga, I mean, ang C sub B ani nga example, because dili man gagabari man iyang moment, no? But in the table, no, first is we have to like see in the table, no, what is the value of this P sub B. Then later, we'll kanang pangitaon na to ang iyang true C sub B, no? Can be obtained from the manual. This is part 3 of the manual. Now, for the unbased length L sub B, so this one, no, itong ganina, actually, table 3, ito siya ganina, sa moment. That is table 5. This one, table 3-10, no? This one is from table, makita siya sa table 3-10, no? This one. So, tanaw na to kung 197 bagid siya, no? Kasi sa B, okay, W10 by 49. That is W18. This is W10. This one, no? Your W10 by 49 is kani. So, inyong sabayon sabayon ninyo ang line. So, this is W10 by 49. Now, nasa diri. Kung sabayon niyo siya ng dash line, then, and here, no, this is sa y-axis, this is the P sub the resistance factor times the nominal moment, and this x-axis, this is the unbraced length. So, pila atong unbraced length, di ba 17? So, somewhere dire, di ba? 17. Then, this is, kung ini siyang subayon, this dash line, this W 10 by 49. Subayon ninyo siya dire. Then, this is the W 10 by 49, no? Atong 17 unbraced length is somewhere dire, di ba? Somewhere dire. Then, try to find this point. Imo siyang i-project dire so that this is LRFD, phi sub B nominal moment. So that kani siya nga point is I think 197, no? Kilopounds feet. 197 kilopounds feet, which is the same with this one, 197, no? Table 3-10. So for the end conditions and loading of this problem, the C sub B is 1.32. All right. This 1.32 is also from the table. In table, nakalimutan ko asa ito nakita. Table 3-1. C sub B. C sub B. Okay. Table 3-1. This one. Yes. The C sub B, this is from the table 3-1. No? For the simply supported beam, load at midpoint. For example, this one, the figure manggod ganina, this one. Actually, you consider this one as beam, then you have this load at the middle, kaning lateral loads, this one. So, bali ma-consider siya as this load, so that your C sub B is 1.32. This one, no? 1.32. So, mo nang the C sub B, the true C sub B is 1.32. And remember, the design strength, this C sub B should be multiplied with the your resistance factor times the nominal strength, no, to account for this is the moment gradient, no, for the moment gradient. Okay, actually dili man 1.0 ang C sub B ani nga figure because gavari ang iyang load, so meaning gavari ang moment, so that C sub B from the table now in the AISC is 1.32. So this will be multiplied to this the resistance factor times the nominal moment. So that 1.32 times this 197 is 260 kilopounds. Then notice that this W10 by 49, if you look at the table again, katong ganina, W10 by 49, ni sobra na siya, di ba? Remember sa katong akong gi-record video, this is the remember the y-axis is this is the moment versus the unbraced length, di ba? L sub B, na remember mo ani? This is the figure, di ba? Somewhere nga na siya. This is the elastic range, somewhere diri nga part. Then this is the inelastic range. Then diri nga part, this is the plastic moment, di ba? This phi sub B times the M sub P should be your limit state. Dapat dili siya mulapas ang imuhang vis-a-vis times the nominal moment. And kung imong tan-awon sa katong table, sa katong diagram, the W10/49 is nara siya diri. Ang iyahang iyang plastic moment, this is actually the plastic moment of W10/49. Tama na siya diri, which is 226. But we found out kaning 260 kilograms, ni sobra na siya sa 226.5. So, kani siya, dili ni siya pwede. Kaya ni sobra naman siya, the moment is larger than the resistance factor times the plastic moment, which is in the table, which is equal to 226. This is 226.5. 0.5, no? Kilopounds feet, no? That is 226 kilopounds feet. Pero kung sa itong gisolve ganina, this is 260, no? So, dili ni siya pwede. So, this should be your limit state. This should be, this will prevail, no? The resistance factor times the plastic moment. Which is also obtained from the beam design charts. Katong ganina nga charts, this one, no? So, basin malibog mo, this is W10/49. So, this is actually the same with the figure, the diagram, katong moment versus the unbraced length. Katong akong i-drawing ganina, this one. This is M sub P, di ba? Tama na diri mong M sub P. So, beyond that one, actually, kung sa W10/49, nilapas na ta, nanata diri, which is 260. Plastic moment is, this is the limit state, no? Diri ra taman. So, this P sub B, or the resistance factor times the plastic moment, will prevail, no? This will be your P sub B times the M sub N, which is from the interaction diagram, interaction formula, no? Nga P sub, this one, no? P sub B times the M sub N. So, kani siya. Pero kung wala gani siya nilapas, if this one is less than 226.5, so kani siya, like for example, this is just equal to 225, no? 0.01. So, this will be your M sub B times M sub N, no? Pero kung nilapas siya sa imong plastic moment, imong this one, this is factor times the plastic moment. So, your kani siya ang mo prevail, or this will be your limit state, no? So, we're done with finding this factor, this one, no? And this one, which is needed, no, in the interaction formula. So, for the factored loads, di ba, remember sa interaction formula, we have to also solve for the PU. This is the loads, no, or the ultimate loads from the applied loads, the load combination. So, the factored loads from the actual load, which is the dead load and live load. So, P sub U is equal to 1.2 dead load plus 1.6 live load given the problem. So, 1.2 times 35 plus 1.6 times 29. So, this will be your P sub U. And the lateral loads, no, which is equal to 5 kilopounds and 12 kilopounds, no, for dead load and live load. So, your lateral loads. So, these lateral loads will be the loads, no, for the moment. This will create a moment sa imong beam column, no? And remember, if you have the concentrated load at the middle, the maximum moment, no, is actually equal to, from your knowledge of your deformable sige itong subject Mechanics of deformable bodies and theory of structures, no? The maximum moment kung nakay simply supported beam, then nakay concentrated load, this is PL over 4, di ba? This one, no? The maximum moment. So the same with this one, sa kani siya nga figure, you have here the support, no? Support, then nakay concentrated load at the center, the lateral loads. So this will account for the moment. So that for the maximum moment, so this lateral loads Q sub U, which is equal to 25.2, will be used in the maximum bending moment, no? Of course, at the mid height. So mainga naman siya. Ang effect ani niya sa beam is mani ni siya, no? Sa iyahang moment. I mean, sa beam column, sa mani ni siya. So maximum moment for the concentrated load at the middle is PL over 4. So 25.2 times the length 17 feet over 4 na 107.1 feet kilo-pounds. This is for the bending moment and this is the PU, no? So we're done with PU. This is PU and MU, no? This is MU. So to determine the interaction equation, determine which interaction equation, of course, controls. But remember, we have two cases, no? If the actual load is greater than 0.2 and if the actual load is less than 0.2, so we have to use the but whatever is the case, so we have to use the equation, no? For example, we have here you have to get the ratio of this P sub U, di ba? Remember sa akang discussion ganina, the two cases, no, this one for LRFD. So if this is the case, so you have to use this formula or greater than equal to 0.2. But I mean, otherwise, less than 0.2, you have to use this one, no? The second equation. So in our example, is the ultimate load or the factored loads P sub U is 200.4 divided by this resistance factor times P sub N, which is this is from the table, di ba? Nakuha na to from the table. This table, isa to ganina. Table 4-1, no? From the AASC specification 4-1, no? And the answer for this one is greater than 0.2. Meaning, we have to use the actual load is greater than 0.2. We have to reduce slightly the moment. No, we have to use the equation 6.3, or we have here the coefficient 8/9 in the moment. No, mo ba? Sakto ba? Yes, this one. Now we have to use the first case. This one, no, because this ratio at the actual load is greater than 0.2. Yes. So, yes, this is the formula, diba? The interaction formula. So, substitute the values, no, which we already computed and found in the table. So, P sub U is 200.4 kilopounds plus this P sub C, or this is the resistance factor times P sub N. This is from the table, 405, but sa table, this is actually 404, no? 405 ang gigamit, plus the coefficient 8/9 times this one, the second term here in the moment, because dili siya by actual ang load. So this is 0, no? Because loaded at the major axis, I mean strong axis, so along X, no? So you have here the moment, the M sub U, which is equal to 107.1 over this P sub B, or this is also from the table. Now this one is from the table, which we found to be 226.5 feet kilopounds, because the plastic moment will prevail because may sobra naman siya sa uh, plastic moment sa W10 by 49, di ba? As I discussed na ganina. So, manang 226.5 atong gamit. And since the answer is 0.915, which is less than 1.0, meaning this member satisfies the AISC specification for LRFD solution, no? This one is okay. This one. The answer for this one is 0.91, less than 1.0. Because it is less than 1.0, meaning the member satisfies the interaction formula, the ISC specification. This is for LRFD. For ASD solution, actually, pareha naman siya procedure, no? It's just that sa table lang, ASD lang ang atong pangitaon, no? So, for ASD solutions, balik na for W10, then the same, no? Fy is 50 KSI, then KL is 17, no? The effective length. So, this is from the table, table 4-1. So, ganina, di ko na itong LRFD, karon ASD na punta. So, in table 4-1, okay. May tao na to. So, the same naman siya, no? Balikon to ninyo nga table, then find the value for ASD, no? And in the table, the answer is 200, the value is 220 kilopounds. And from the design charts in part 3 of the manual for LB, or the brace length, 17 feet, and C sub B 1.0, the moment, the allowable moment strength for ASD solution is 131 feet kilopounds. No? The same table in part 3, this one, di ba? Kung mabantayan ninyo, this first column here, this is for ASD, and the second is for LRFD. So, kung tanaw ninyo siya, this value, the M sub N, nominal moment divided by the factor of safety for ASD is 131.17. Okay, atong ipagamay, no? Then, 17, no? Kung atong subayon, 17. So, this part here, ano siya? Kung inyo siyang subayon diri, is actually, because this is ASD, no? This is ASD, is actually below 132. So, nasa sa 131, no? Value for this value, no? So, balik ta sa problem. This one, no? 131 feet kilopounds. And C sub B, this is the same 1.32, di ba? For the simply supported beam, then na-load sa ito nga. Ay. This is table 3-1, di ba? This one. Load at midpoint. The C sub B is equal to 1.32 for the moment gradient, no? This is table 3-1. And this one is table 3-10. Ay, dili. Yes, 3-10. So that this is a B will be multiplied to this ASD solution, no? 131. So the answer is 172.9 feet kilopounds. And this is larger than, this value is larger than the plastic moment. If we use the plastic moment, which is just equal to 151 feet kilopounds, so meaning this is dili siya pwede, no? Because plastic moment will prevail. Tama na gid ka sa plastic moment. No? I mean, this is your limit state. But if this is less than the plastic moment, okay, how did we get this value, no? This one is, gikan gyapon siya sa table. For the W10/49, the plastic moment state, this one, is taman diri kani siya, ang value. Kung imo siyang i-project diri, this is actually equal to just 151, no? For ASD, equal to 151 na siya. So, dapat, dili na siya mulapas. Kay, actually, sa table, no? Sa katong akong gidiscuss, no? Sa video, this is moment versus the embrace length, L sa B. So, this is actually the diagram. This is the plastic moment. Then, nga siya. This is the elastic region here and the inelastic region. So, this part here, this is the plastic moment. Then, the 172, this is the 151 lang diri. Plastic moment. 172, ni sobra na siya dito. Which is, dili siya pwede. So, the value, which will be atong gamiton sa interaction diagram, interaction formula should be the class. Hello sir. Hello sir. Hello sir. Hello sir. Ay sir, manawag ako sa imo sir. Nag-classip ako kadto lang. After ani hapit naman. Manawag ako sir. So, yes. 100, yes, this 151 kilopounds should be the value, for the moment term nga sa interaction formula, no? This one, the same with LRFD kanina that I discussed, no? This m sub n over the factor of safety nga ni greater than siya sa plastic moment divided by the factor of safety, dili siya pwede gamiton. But if ni less than siya, the value is just equal to 140, for example, kilopounds feet, no? This is just equal to kilopounds feet. So this will be will prevail. I mean, this is mo ni siya ang atong gamiton sa interaction formula. But since nisobra man siya sa plastic moment, so dili na siya to pwede gamiton. The plastic moment should be the will be using in the interaction formula. Then yes, we're done with finding this term and this term, no, from the tables, no. So now we have to find the P sub A, the applied load, total axial compressive load, P sub A. So for ASD, just equal to the summation of dead load and the live load, diba? 34 kilopounds. And the total transverse load or the lateral load, because this is ASD, diba? ASD. So just sum up the dead load and the live load, no, pounds. So maximum bending moment at mid height. Now the same with the LRFD solution. This is PL over 4, no? for the load nga na kay concentrated load at mid-height or at midpoint, no? Then determine which interaction equation occurs. So we have to find the ratio, no? If this is greater than or less than 0.2. And the the applied load is only 34 divided by this in the ASD, no? This one is from the table, no, which is equal to 270. Table for dash one. The value is 0.5, no, 0.4963, which is greater than 0.2, meaning the same equation, no, in the LRFD will prevail, no. So substitute for the value of this one, the applied loads, and this from table term plus the 8/9 times this one is 0. The second term, the moment is 0 because it is it is not by axial loading, no? And yes, the moment, this one, the moment is the applied moment caused by the applied loads is 72.95 divided by the value from the table, no? Which we nakita na to ganina sa table. So that the answer is 0.922, which is less than, still in the ASD solution, less than 1.0. So, okay. So, in the ASD solution, this member, or W10B49, satisfies the specification. Then, have here kindly solve this one, no? This is the laboratory SeatWorks, no? Exercises, no? Laboratory exercises. And the answer, 1. And, yes, questions? Napa ba mo class? Questions? Any question? Hello? Are we good or are we bad? Napa mo? May mga pangutana? Nakasabot na mo sa kuan? So this is our can be our last topic. So kindly answer the problems now. I'll post this one in the classroom. And yes, so next week will be our quiz. So siguro sa final exam schedule, mag-quiz ta. Then next week mag-final exam ta. No? And remind also reminding you of your case study. Kamusta natuod mo sa inyong case study? Lawi? Hello, class? Wala mo diha. Hindi mo gatubag. Charot.
Hello, ma'am.
Kamusta naman sa inyong kuan? May question sa atong discussion?
None so far sa discussion mo.
I see, yes. I'll try to...
Ang kuan, ma'am, ang finals na to sa CE44, ma'am, mag-una lugar, ma'am, ay ang quiz, ma'am.
Ay, dili. Ang final sa schedule natin sa final exam will be your quiz. Then,
Okay.
next week is your final exam.
So, karon Tuesday, ma'am, kay quiz pa ta, ma'am.
Ano ba yung schedule? Wala ko
Yes,
kabalo.
ma'am.
Ano ni
Tuesday ta,
schedule?
ma'am. 9 to 11
Tuesday.
ata to.
Sige, mag-quiz ta na. Dahil next week is mag-final exam ta.
Okay, ma'am. Sa ano, ma'am ba? Sa case study mo?
Yes.
Wala, naglisod, may pangita og building plan mo.
Ya, ini building plan lang. Kung wala gilain, sige. Sa internet. As long as it is still kung wala gilain, then it's up to you, no? How you will do it, your contents sa inyong case study. Then, ano lang. What type? Yes, Ariel.
Good afternoon, ma'am. Kanang wala
Good
may
afternoon.
format na wala may format na i-follow para sa case study, ma'am.
Wala. Format nga i-follow. Whatever na makuha ninyo sa inyong mind, mo na to siya. Okay, mo ba ni klaro si ma'am? Ah?
PowerPoint presentation or may basa, ma'am?
Kuan. Dili siya PowerPoint presentation. Sa atong CA 86 no kay kuan ray. Ba? Okay, yes, PowerPoint presentation. PowerPoint presentation is fine. Then you have to
Thank you,
present.
ma'am.
Ano na lang, no? The final requirement is PowerPoint presentation. Ano lang. We'll
Pwede,
sked, no, sa final sa inyong presentation.
pwede na siya recorded ang presentation, ma'am.
Pwede gihapon, yes. Yeah. Pwede, mas okay siya. No? Recorded.
Thank you, ma'am.
Then I'll set na lang deadline, no? Deadline sa inyong kuan. Sa inyong submission sa case study. So, I think start recording.